thanks to everyone that's joined us today. This is TechTeach session 5, and today we're going to be exploring the fundamentals of unit testing. So for anybody who doesn't know me or hasn't met me in a previous session, I'm Sinead Shackley and I'm a director in Liberty IT. So I'm here representing the Software Alliance, and this is now rebranded as Software NI, and we've developed TechTeach, which is a monthly information session for teachers delivered by different member companies of Software NI. And together we're here to share our skills and experience with local educators in order to enable you to bring the latest technologies into the classroom. Today, I'm delighted to introduce our presenter, Ryan Adams. Ryan is Head of Learning at Install, a local software development company, and Ryan is going to share a comprehensive overview of unit testing and demo testing tools that can be applied in your classroom. This is a two-part series, so we've got Ryan today, and then I think we'll either have Ryan or another colleague next week, so don't forget to tune in next week as well for the second part. I'll hand over to you now, Ryan, if that's okay.
Thanks, Sinead. That's great. Thanks very much. I'll just share my screen so you can see what I'm going to talk about. I hesitate to call it comprehensive, but we'll see what we got. We've got half an hour. I am usually delivering a training course around testing that takes 2 days full time for software engineers all over Northern Ireland. So I'm trying to compress 2 days worth of training knowledge down into 2 30-minute sessions. So we're not going to get anywhere near everything, but hopefully a flavour of what's important and some good stuff. Everybody can see my screen okay? There's no issues there, I hope. I'm slightly unfamiliar with Teams, but I think we should be okay to get going. Very quick introduction to myself and to Install, just to kind of set some credentials. Install, I've been around since 2005. We're a local software development company, and we have been training software developers since day one, practically. We train classroom, online, and in-person training. Sometimes we like to think that we're taking kind of good graduates and giving them the stuff they need to be productive in life. But really, we're about accelerating developers and helping people kind of get productive as soon as possible with the stuff that we're doing. So we have a long heritage at Install of training, and we're into lots of local companies and international companies as well, talking to lots of developers and trying to kind of show them a better way or give them the opportunity to develop some skills. And it's great. I'm really enthusiastic about the opportunity that I can come and get manipulating future developers early by talking to teachers and kind of giving you a little bit of an insight into how we think. So yeah, install.co if you're interested. Just a wee bit of marketing. So we're here to talk about unit testing. I've got about half an hour today, so I'm just going to kind of whiz through it and see where we get. I took a look at the software systems spec from the exam board just to kind of sense check what they were saying about the requirements around teaching because I was thinking, is testing actually really important? It's clear in the spec that there's elements where talks about test cases, talks about understanding and exploring and evaluating test results. So that's really important that even from an academic perspective that it's there. So that's cool. But actually from a software developer career perspective, testing is really important. A lot of the times there's this kind of sense of testers and developers are separate people, and that is not true. If you are a software developer, the likelihood is you will be writing tests every day. So writing tests and thinking about testing is a crucial part of the role of being a software developer. It's not some special esoteric skill that only a specific type of software developer needs to have. It's something that all developers need. And so if you have the opportunity to encourage your young software engineers to think about testing from the get-go, that's brilliant. To get that testing mindset into young minds is great because the sooner you start thinking in terms of that testing mindset, the sooner you'll start producing high-quality software, and that's what we really want. I've got a quote. I will share the links and the slides as well, probably at the end of session 2. So come back next week and you'll get them. But I grabbed this quote. I confess I have not read the book, but it rang true. Testers don't like to break things. They like to dispel the illusion that things work. And you could replace that with tests. Tests don't like to break things. They like to dispel the illusion that things work. Most of the time, with complex software, it's broken. And anybody else that's working in software will tell you that true, that most of the time we're dealing with things and we're going, why is this thing not working? And the tests and the role of the tester is really good at pointing out those areas and helping us discover where those problems are. So testing is a really important skill to have. It's important to have that testing thought in your head when you're coming to testing. So yeah, most developers write tests every day. Some practice a technique called test-driven development. We're not going to talk about that, but really that's where you write your tests first. It's slightly niche in terms of its approach, but actually it's really powerful and is a technique that I favor when I do any kind of proper development, and a lot of really good developers do as well. So I'm copying good developers hopefully when that works. But all of our code really should have some degree of testing around it, and we're trying to aim towards that technique. So we're gonna find that we're writing tests. The question is why do we write tests? What's the point? And I've captured 5 things which kind of cover all of the majority of the edge cases. So thinking as a developer, why should I as a developer write tests? So why should I as a software engineer actually bother with writing some test code? And that top one is actually kind of important. Figure out what the code should do. So I write a test in order to understand what the code that I'm actually going to write, the production code, is going to do. The test helps me figure that out. So sometimes I can use tests to design my software system. And if you're thinking about how you're approaching tests when you're maybe teaching object orientation, you might have in your mind the shape of the object, the class that you're going to define. You can test that shape to say, say I'm building a class that represents a cube, and I know in order to calculate the volume of a cube, I need length and breadth and height. I can write a test that assesses that I can create a cube with length and breadth and height, and assess that when I execute the volume function or the volume method, that it returns the right result. So we can use the tests to help us understand what the code should be doing behind the scenes. Following on from that, we need to know that the code that we've written works, and that's not always obvious, particularly when we're getting kind of complex software. Sometimes we might write some code and it might not be deployed into a production environment for days or weeks or months. We try to avoid that where possible, but if you can't run it in production, then you need to verify that it actually is going to work when it is deployed into production. Tests can help us do that. So again, we're thinking of tests as little miniature executions, particularly unit tests, as little miniature executions of the production code, and verifying that it actually behaves the way it's designed to. Once we've written our tests, then we can keep those tests around, and we can be confident that when we make changes in future, we haven't broken anything. So you probably have regression tests, or you've talked about that in your classrooms. All of the unit tests that we write today become tomorrow's regressions tests, where when we're adding a new feature, we can be confident that if yesterday's tests pass, then I haven't broken the work that I did yesterday, and in adding this new feature, that's going to be there. So that's another really useful technique that tests can give us. Sometimes, in fact, frequently, you join new teams. So that kind of the half-life of a job in software development is probably about 2 years. Lots of people kind of move on either to new projects or to new organizations within about a couple of years. Generally, seems to be the kind of half-life of that sort of thing. And when you join a new team, you want to be productive fast. And one of the best ways to help you understand what the code is doing is to run the tests, and the tests can act as a form of documentation. Now we'll talk a little bit about that. I'm going to show some tests, and sort of show that out. But the idea that we want to make our tests really easy to read, because then that means that whenever I come to this new piece of software that I haven't written and don't understand, I can read the tests and it makes sense. So we'll talk a little bit about that today, probably a little bit more again about that next week when we're doing that. And then finally is to kind of get feedback on the code. Again, agile concepts, I'm sure, are in your mind when you're teaching software systems. At least I hope they are. The concept of rapid feedback, of the kind of the iteration of software development, and checking to see whether our code or the product that we're building meets user expectations. Well, tests are often the first client or the first user of our production code. So that's a really useful concept to think about, that we can use the test as a means of getting feedback about how easy it is to work with, or whether it's appropriate. If your tests are hard to write, then your code might be poorly formatted or poorly factored, and you might need to think about is there some design that I need to tease out of this code and change in some way, and make the tests easier to run. And then if your tests are easier to run and write, then your code will be easier to run and write and use in production. So couple of concepts there. There's a whole bunch of other reasons that you might want to write tests, and lots of different tests to think about. But those are just 5 that I found fairly useful when thinking about the tests that I'm going to write and why I would choose to write them. So what sort of tests are there? Again, I've got this one. I might even drop this one into the chat if I can. I'll do that in a second. I've got a browser tab open. Just a nice little diagram to highlight some of the different types of testing. And I know, again, a lot of the kind of the spec for the course talks about white box testing and black box testing and manual testing and automation testing and all that sort of stuff. So there's a huge area of testing that you as a software developer need to have an awareness of. And I found this was a kind of a useful diagram to look at. There's things missing from this. It's not complete by any means, but there's certainly a useful concept to think about in terms of guiding. And the article that I lifted this picture from, linked below, lists and describes each of the types as well. So if you're needing some sort of guidance around useful ways to kind of categorize your tests, this might be a useful place to begin your explorations. We're going to focus today and next week on just one little tiny bit, which is the unit testing piece. And unit testing actually is really crucial and really important because it's pretty foundational in terms of how we start our testing process. Where that might lead you is the testing pyramid. So again, this might not be it's pretty close to the kind of the standard labeled diagram for the testing pyramid. And this is useful as a means of thinking about things like test plans or scope of testing, where we've got this concept of a wide foundation of unit tests that we then layer service or integration tests on top of, and then further on top of that UI or acceptance tests commonly. So again, there's a link there to an article on a really good website. martinfowler.com is one of my go-tos for useful software engineering topics and techniques. So it's again worth looking at. And the key point here, which I'm just going to highlight, we're not going to focus too much on testing pyramid, is this axis of slower and faster. Unit tests are fast, or they should be. System level tests are slow generally, and slow generally means expensive, or painful to write, or likely to be not run. Because developers are very lazy people, and one of the things that we want to do is not do work that we don't have to. And if a test is really slow and painful to run, then my laziness is going to say I'm not going to run it. And so we want to kind of put a lot of effort into these unit tests because they're quick and they give you rapid feedback, which is really what you want. But What I did want to talk about is a way to think about testing, and I know that the spec talks a lot about test plans and to kind of come up with test plans. Test plans are a thing as a developer that I typically don't use a lot of. So we tend to focus on unit tests and let a QA team handle test plans usually. And then a lot of software teams don't have QA or don't have dedicated QA teams. And so the majority of software is probably poorly tested, which is something we want to change because tests prove that our code works and highlight the bits where it doesn't. So it's important to have this concept in your head for sure. And the testing quadrant is one of those kind of box of 4 graphs. It's on 2 axes, and the horizontal axis, as you can see here, is we can decide whether our tests support the team, so they help the software team build the product right, is the common phrase, versus on the other side where we've got the critique product, is the question of, am I building the right product? So I'm building some software, am I doing it right, or am I building the right thing? And the testing quadrant allows you to think about your tests in that context, and you'll see here unit tests sit supporting the team side. So typically unit tests are there to help the development team make sure that they're building the product correctly, rather than testing the requirements. So the unit tests typically don't question whether the requirements you've received are correct or not. They just assume that they are. And then the other axis is between business facing and technology facing. And really that's a question of, do the tests ask questions of the technology, or do they ask questions of the problem domain in question? So if you're building a task management system for your school, for example, the questions about the kind of the business facing questions is, what's the appropriate shape of a task? What's the stages that it goes through? All that sort of stuff. The technology facing questions will be, can I save the task into a database? Can I search for tasks and things like that? So we've got this kind of differentiator between things that help us understand the domain of the problem, the business problem, really the thing that the end user needs. And then the technology facing is going to be the thing that the developers need. So this is a really useful concept to think about, and we've got a kind of a box of 4 that we can drop our tests onto. And what you usually find when you look at a development team and the way that they write tests is Q1 is where developers spend most of their time. So they're writing tests like unit tests or component tests that are supporting the team in building the product correctly, and they're asking questions of the technology. Am I using the technology right? And where a QA team would sit and where the test plan type stuff would sit tends to sit up in the business facing area. So automated and manual area in Q2, where we're supporting the team to make sure that we're fulfilling the specification, but we're testing against business criteria. So it's functional tests and acceptance tests and doing UI tests and things like that. And then over on Q3 is where we do manual testing generally, and where you'll have a dedicated manual tester who is exploring the product and finding out places where it's not built right because it doesn't work, or the user can't use it for some reason. Now, again, our focus today is unit tests, but what I would say is one of the things that's useful to think about here is if I can capture a problem or a thing that I need to test as an exploratory testing session, so a user can't log in, I can convert that into an automated test, functional test that verifies that a user can log in, and that means I can rerun that test and run it frequently, and again that frees up the tester to do more exploratory testing. So there's a pool from Q3 to Q2 to take an issue or a problem or a thing that we verified manually and automate that verification. And that's probably a session for another time. So if you're interested, come back to us on that one. But then at the same time, I can take those functional tests, verifying that a user can log in, and I can write some unit tests around that. Is the password field capable of supporting an appropriate password? Does the email field support email addresses with apostrophes in it? Because some organizations put apostrophes in their email addresses and it breaks software. We've got one piece of software that we use that doesn't support them, and yet they should. So we can convert those into unit tests and help the development team build their software. So testing quadrant is really useful to kind of get a sense of where you might need to think about testing, and thinking about am I covering all 4 quadrants? And again, the link that's there has got some references for you to look at should you be interested. Okay, about 10 minutes left, I think. So I want to just jump in and actually show you some tests. Now I will definitely drop this into the test, the channel. I have pushed up to a GitHub repository a very simple Python piece of code and some tests for it. It's actually lifted from a larger one. So the README file, if you're on that, does link to a larger repository. So I'm going to talk about Python here because it's simple enough that even if you don't program, you can read it. But if you happen to be using something like C# or Java on your course, the Gilded Rose refactoring kata on GitHub has got implementations in multiple languages, so you can kind of pick the one that you want. I'll step through the Python one because I've got it locally and talk about that, but feel free in your own time, if you're a C# developer or a Java developer or a COBOL developer. If you're a COBOL developer, you're probably in great demand because they're few and far between these days. You can sort of practice what we're doing here. Now, I have it open in PyCharm, and PyCharm is my tool of choice for Python code. VS Code works very well as well. So there's free software that works. And the Gilded Rose is like it's an exercise that is useful for developers to practice their testing and to practice what's a technique called refactoring, which is improving the quality of code. So there is a README file, which you're welcome to read. It's based off a computer game, and I am not a gamer, and I don't know what the name of the computer game is, but it's apparently well known, and I'm just outed myself as being insufficiently geeky. But Gilded Rose .py, the Python file that's got Gilded Rose, has a function in it called update quality. So we've basically got a shop that has a list of products, and those products every day, the quality of the item changes. So if it's aged brie, brie gets better the older it is. So as it gets older, its quality increases, and other things happen as well. So the kind of the context of this is we have some code, and actually I'm not sure what your students' code looks like. This is not great code, and the reason that it's not great is this sort of scenario where I've got an if within an if within an if, which is actually pretty horrible. And if you were challenged to come along and add support, and actually the challenge for Gilded Rose is you have to add support for this new product called Conjured Items. And you go, okay, that's a piece of cake. I just go to Gilded Rose and I look for the right place and I drop it in. And suddenly you realize, no, it's not easy, because there's all this mess of code that you've got to look at. And there's very few tests. And in fact, there's no tests in the actual kata. I've written some. So on the website, you can see 3 that pass. And I've got some more written down below here that we'll look at. But really what we're doing is we're saying, I don't know how this works. I might have the rules that are defined here, but does the code actually implement the rules? I'm not sure. I can't easily read this code and differentiate what's going on because we've got this kind of aged brie reference several times. So the code's branching all over the place and it's difficult to work with. So what we need to do here is we need to go, how do I understand? Can I understand how this works? well, let me write some tests to do that. And so we've got some tests here in my test file. So you should be able to see this if you've got it open in GitHub, or if you've got it downloaded already. Test gilded rose.py is our set of tests. Now, next week, my expectation is that we'll come back to this exercise or a similar one and actually write some tests on the call, just to kind of to show you the cycle and talk through how it works. I knew that I didn't have time today, so I'm just going to very quickly whiz through these tests that I've written. And if you want to go there and go off and practice next week, that's cool. I'd be really happy to do that. You can send me an email with any stuff. I'll give you a code review. I'm happy to do that. But what I would say is the way that we think about tests is each of our tests is a separate execution of the shop software. So there are a set, a sequence of miniature applications that I'm going to execute several times. And that's a really good concept to think about when it comes to testing. So I've got test quality reduces with age. And I'm following a pattern here. And again, this might be something that you're familiar with, but it's really common in terms of writing unit tests and a thing called behavior-driven development. We arrange the system in a state that we know. So here, I'm creating an instance of the shop, and I'm passing in a standard item with a quality of 30 and a sell-in of 10. And then I act upon that system that I've arranged. So in this case, I'm going to call update quality. And then what I do is I expect that as a result of calling update quality, I've changed the system in some way. So I've got it in system in state A, I'm acting upon it, and it's now in state B. And then finally, what I do is I assert that system is in this particular state. I'm using a testing framework called PyTest, which does require a little bit of setup. There are details in the README file if you want to try it, but it makes for cleaner tests. So it's my preference here, because assert is a built-in keyword in Python, and all we're doing here is we're stating a thing that returns true. So assert item.quality is 29. So I start with 30, I call update quality, it's going to be 29, and that's the kind of the ideal test. Simple setup. Do one thing, assert one thing, and then you write dozens or hundreds of them. And I've got a dozen or so here that are written. And what I tend to follow is I like to have these like sort of paragraphs in my tests where it's clear I've got some arranging, some setup, I've got some actions, some tasks that I'm performing, and this is the test. This is the thing that I'm testing. I'm testing the update quality method, and then I've got my assertions or my verifications to make sure that things are correct. And what we want to do is we want to write as many of these as we need. And we want to keep them so that they're really succinct and do one thing and do it really well. And then what that means is when I run the Python tests, in my test framework, I've just run one test, not them all. Let's do it this way. Run Python tests. I get my 7 or 10 or whatever tests passing, and that green tick is immensely powerful as a means of giving you, the developer, that vote of confidence. I've done it right. I've built this software, and it's really easy to notice when you've done it wrong. You know, if I were to say 30 here and then rerun, I would immediately get that. Oh no, I've done it wrong. Expected 30, but I actually got 29. You've got a bug in your code. You've got to go and fix it. And the test should direct you directly where that is. And I can even click here and it'll go up and it'll show me. Well, it doesn't really actually. Oh, it does. This is the test that's broken, and I can understand why it's broken and fix it. Okay, less than a minute. That's all the tests I'm going to show you for today. There are I think three passing tests on GitHub, and I have a further 10 or so here. I'll share that code on GitHub as well later on. So if you want to try it on your own and then come back and look at it, you can, or you can try it in different languages and see where we're at. So yeah, that's my very brief 30-minute session on testing. So next week, my intention is, whether it's me or my colleague Andrew, we'll write some tests live to give you a sense of the cycle, and we'll talk about technique a little bit. So size of tests, the size of the kind of the gap between code working and not working, and how that sort of works. But yeah, come back next week for the conclusion. And I guess we don't have time for questions. But
I was going to say, Ryan, though, we can take questions offline if that's okay,
sure.
and pass them through to you just in the interest of time. And then obviously look forward to having everyone back next week. We will finish out that piece, but if you're good with it, any questions come through, we'll share them with you, Ryan. Welcome everybody to TechTeach session. Andrew has session 5. I thought it was maybe session 6, but today's the second part of our series on unit testing. So for anybody who doesn't know me, I'm Sinead Shackley, Director in Liberty IT, and I'm part of a team within the Software Alliance, which is now rebranded as Software NI, and we've been put together to develop TechTeach. And this is a monthly information session for teachers that's delivered by different member companies of Software NI. And together what we want to do is share our skills and experience with you, the local educators, in order to enable you to bring the latest technologies into your classroom. Today, delighted to introduce our presenter, Andrew Paul. Andrew's a trainer at Instill, and this is a local software development company. And he's going to continue on from the session last week and share an overview of unit testing and demo testing tools that can be applied in your classroom. So, Andrew, you're already sharing the material, so I will hand over to you.
Absolutely. Thank you very much. So hello to anyone there and anyone watching the recording too. So my name's Andrew. You'd have had Ryan last week. So we're working in Instill as software trainers. So we've got quite an interesting role where we spend a lot of time going out to clients, in our case, who maybe have gaps in their knowledge. So maybe they're changing projects and they're maybe moving from a C# project to a TypeScript project, or some specialist framework, or they have some new strategies they want to try out and they're not sure how to implement it. And we'll come in and we will carry out the training for those. So what I'm going to go through today is something that we are quite regularly brought in to various companies to go through in a huge amount more detail. Usually we would do this over 2 or 3 days. So I'm now 28 minutes shy. It's going to be fun, but we'll get stuck in. At least I'm picking up from where Ryan left off last week. And where Ryan did leave off last week was literally throwing some unit tests at you in Python and giving you a chance to see those and play with those. I have the PowerPoint here just purely for continuation. So sorry, Sinead, I just had session 5 and didn't even think I'm not using the slides. So bye slides there, we'll make them disappear. And just to try and be as practical today really as possible. What I will say, and I'll pop the link into the chat in a wee minute or two in case you need it, but the Git repository that Ryan shared last week that had the Python tests and the Python exercise in it, I have updated that a little bit this week, because I turned around to Ryan as why not the wrong way, and I said, why not C#? Why did you go just for Python? And he was like, yeah, I probably should have done that. You do it. So that's where we're at. So I've added a little bit more into that, just so that you maybe have a couple of other languages as well that you can have a look at. And certainly when I was working in education, C# was the sort of bigger focus for a lot of people. So I've shared that, but Python is definitely a modern trendy language that we do a lot of teaching with, a lot of companies moving to it, but C# is still there. And to be honest, I prefer C#, but don't tell anybody that. I just like the curly brackets. It just keeps me happy. So I've thrown that link just in case you missed it last week. It's there. If you cloned it last week, you can do a git pull, and that'll bring you all the latest bits. And also in that, because I don't know if Ryan shared it or not, I've popped in the few slides from last week there in that repository as well. So if you go to that link, you can download it separately. You can update whatever you have. Everything's there, hopefully, that you need. So we're kind of good to go really that way. So just to show you, we have C# and we have Python, and then the PDF with the slides is there. So Ryan has gone through, and I'm going to show you what Ryan's done actually. And Ryan's gone through and he finished his demonstration from last week in terms of Python. So we're going to go through that. Then I'm going to do a quick run through of C#. And then I want to sort of show you what comes next, because actually I'm going to say something controversial. I'm going to say something that's totally unfounded, no evidence at all, but trying to give you a context of where my head goes to. And if you think to what has been in the news a lot recently with the post office scandals and Fujitsu and the government and what's been involved, and the stories that are there are terrible. They're horrible to listen to, and you feel a lot of sympathy and empathy towards the people that have suffered as a result. But the thing that's annoyed me, and the thing that I go to in my head first, and I think as an industry we should all be doing this, is turning around and saying, well, that was terrible. Maybe the policies and the procedures around what happened were terrible, but actually, what about testing? Was the testing there? Did it take place? And how did that go about? And what we tend to see in a lot of companies, particularly ones that are starting out, are companies that are under pressure to produce and give something, a bit like your students might be whenever they're trying to throw coursework out before the deadline, because we all know they start the week before. Then they throw it out, and testing comes last. It's sort of like a tick box exercise. They go, yeah, we did it, but it's fine. And that's not the way testing should be. And I was debriefing with Ryan last week, having watched the video, and I was saying, why? How did you find it? Because we would do a thing called test-driven development. Ping me a message if you want to hear about that in more detail. It's not for now, but we do testing as we go. Actually, we do testing before we start to make something. We have the test written to prove it works when it happens, and in that way, that means we know every step we take works 100%. It was an interesting discussion we had, but no time for that. So with that in mind, how can we make our testing better? That's what I want to finish with today, and then a bit of Q&A sort of towards the end as well. So if you had this open, hopefully you got a chance to play with it during the week, because it was just there. You'll have written some tests, and maybe you've done Python and you were happy. Maybe you struggled with Python because you hadn't really done it before. That's fine. We'll show you the C# side, and it gives you options then to play with. So just scrolling up, Ryan started off the first couple, and I've done the same thing with C# for consistency. We always have a same pattern in our tests where we sort of arrange what we need. What do we need for this test to happen? And then we turn around and say, act. What am I actually doing? What am I focusing on? And then assert. What's the response that I expect to get back? And arrange, act, assert. Arrange, act, assert is the pattern that you should always go through. There is another context which you might read about. We usually use it for a thing called behavioral driven design, so it's a slightly different focus, but there are companies that have adopted this and use this in the same way. Sinead might be able to testify to this, where there's been policies brought in where certain companies are using the phrases given, when, then for their tests. Now that is what we call gherkin syntax. It's usually used with a library called Cucumber or other variations of it. But we pretty much say for a scenario, given this thing is present, that we've started with this arrangement, when this event happens, then we should get a result. And it's the same thing, okay? It's arrange, assert, act, just in a slightly different order. Traditionally, it would be used in this context of BDD in terms of acceptance testing rather than unit tests. But there's some really brilliant use cases of it being seen, and I'm just not going to argue. So I'm going to pop this in just for your reference as well into the chat, and that'll be there then in case you want it. Arrange, act, assert, or given, when, then. But the first is typically where we would go to on that. So here, Ryan had turned around and said, okay, I have my item. It's just a standard item. It could be a banana, it could be an apple, it could be a cow, it could be a video, it could be anything. That bit doesn't matter. I've given it a quality of 30 and a selling of 10. So I trigger this application. Now, what stumps some people when they read this the first time is realizing that this is just a class. There's no actual program here. It's just us testing the functions and how they work, which is brilliant. We don't need to run the system. We're testing each function. And that's what a unit test is about. It's testing the individual parts, not in the whole program. That's integration testing, when we integrate them all together. It's showing all the individual parts. What I do hate about these is that actually unit tests should test one thing. And if we want to change our code at some point, actually, what I'm going to be doing in this set of tests, and Ryan's set of tests are the same, is we are testing the Gilded Rose app. We're testing the Gilded Rose app. We're testing the Gilded Rose app. Actually, we're testing the same thing here for 6 million different things, and that should give us a bad smell. We would call that where actually there's too much going on in one place. But we'll talk about that in a little while. Bear that one in mind. So I have this standard item. It's going through. I call, I do, I act the thing out that I want to happen. That function works. And then in Python, I just go assert, and that's giving me a true or false back. It's turning around saying, is the quality at the moment equal to 29? And I hope that test will pass. And the best thing about this is some best practices in general, where it's really easy to understand what's going on just by reading this. So I am testing the quality reduces with age. That is practically a sentence. That is how our code should read. We should be able to turn around and say, what is this test doing? The name should be clear as day. And actually, if you have a calculator, for example, and you go, I tested ads. That's rubbish. It should be a test name that says, I test that the first number adds the second number and gets the third number. Or you could be specific and say, I test that I give 1 and 2 and get 3. There's no harm in putting that into your test. You should be shot if you use I's, J's, and K's. You should be shot if you don't give long explanatory test names. And I very much will die on that mountain and probably will shoot a lot of people in the attempt. And that's scary. I saw it a lot in education. It's not a slagging off, it's because all the textbooks do it and therefore we copy that. But in industry, that's not the way it happens. So that's the test. Another test. Test quality reduces faster after sell, and that's clear what I'm trying to do. And then a range act assert. Now you don't need to keep labeling a range act assert. That's just to get the pattern of what's going on the first couple of times. Again, we've just done our initial setup. We call it and we make sure that it responds the way we expect it to. And that's the pattern that's going on through this. You can see here we have a range act assert just without the labels, without the comments put on. And age spree gets better with age. Well, that's lovely. We follow through, we check that that works. And I'm clear from the name that age spree is what I'm focused on. And here's the thing. If we have a really good set of unit tests, I don't need to look at the code to understand what's going on. So I'm sure when you started to look at this Gilded Rose, and I can't remember, is this World of Warcraft or something? I did say this one day and I got told off because I picked the wrong nerdy game. I called it a nerdy game. I picked the wrong one and someone took offense, but that was okay. So by the time I work through this and understand what's going on and then look at the code to figure out what's happening, I mean, look at that thing. Look at that. That's horrible. That's absolutely disgusting. And yet, that's what we see happening in lots of places, and it shouldn't. Well, actually, how do I make that better? Well, I should be writing better code. But the other way that I could potentially make my explanation better, and it's the first place I will go to, is the test file, where I can turn around, I can pick out the rules. I can know that quality is never less than 0. Okay, and that is clear as day. I know that age spree gets better with age. I see a pattern there. I know it's increasing instead of decreasing. Wonderful. That's what I need to know. Okay, quality is never over 50. There's another rule. I don't need to read that stupid README document. I don't need to figure my way through the lines of code to understand what's going on. I can just read the tests. Wonderful. And then I can go from there. So quality is never negative. Age spree goes in and it comes out. It goes in with 50. It goes up a day or two and there's 50s coming through. Now, what some people will turn around here and say is, where do I stop? Because actually I could put age spree in here with 50. I could put the Hand of Ragnarok, Sulfurus, whatever it's called, silly game stuff, sorry. I can put that in and I don't know. I know that it will work, it will not go down. I can turn around and I can look at age spree and special other things and say, well, it never goes more than 50. Or what if I test age spree once? Should I be testing it for sell in 11, for 50, for 100 days? Because it could sit on my shelf forever. What happens if in day 99 it happens to jump up? How do I test that? Well, actually, that's a whole other set of testing called property-based testing. where rather than focusing on the individual parts, we focus on the rule. And once we've tested that our functions are working the way we expect, we then push the system to its limit and we flood it with values to make sure that the rule works for every situation within reason. It's an infinite world, so we can't put an infinite number of tests, but we balance it out. So test quality gets better, faster, and that's just what's going on. Now, look at this. Test sulfurous never changes. Okay, so I put sulfurous in, starts at 80, finishes at 80, and I go update, 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 and I check that it's working. Now, that doesn't give me the pattern where actually if I turn around in here and check, is it the same? I put it in here, is it the same? I put it in here, is it the same? That's starting to get really messy and horrible, and it's not giving me the, just turning around here, what happens if this goes 81, 82, 83, 84, oops, 80, whoopsies, there's some strange loop in there that happens to hit 80. My tests aren't showing me anything useful at that point, and this is where it's important to remember that unit tests in themselves are code. So what could we use? Anytime I see something like this, I turn around and I see, oh, I'm doing that 5 times. I should have a loop that's going to cycle through this 5 times. And then I can start to create something that matches and works that way. So don't be afraid to use code. I'm going to show you in C# because that's more interesting than a wee while. But it's the same pattern for both. And I put the same comment in both these. Well, actually, Ryan put it here first and I copied it in C#. But this is really ugly and it should be fixed, okay? Because here I've got the backstage passes. The backstage passes were complicated. The backstage passes, they turned around and said, well, actually, they increase in quality as we get closer. As you get really close, you get more valuable because they're in short supply. And wow, you can get really cool things, but as soon as the band leaves the stage, why does anybody want a backstage pass? Okay, if nobody's there, it's rubbish, so it's worth nothing. Special rules, and I'm testing for all of those there, but actually there's too much going on in that test, right? While I am testing the backstage properties, I take fear when I see a name like that because it's not specific enough for me. It's not showing me that I'm testing that the backstage passes increase by 2 whilst 3 weeks away from the event. And then I'll have a separate test that shows the backstage passes increase by 3 when I'm a week out. And I test that the backstage passes drop by 0 the day after. I would rather have 3 tests that explain that. Therefore, that will go in its own test. That might go in its own test. And then all this stuff will start to go in its own test. And I'm going to start to put loops in to try and make it nicer. Okay, so that's what I'm thinking here. I'm looking at this going, how could I better explain to future me or future someone else that's coming back to look at this what's going on? Because in education, we have a bad habit of saying you must put comments over everything, and we sort of award 20% out of the 100 for comments, tends to be typical mark schemes. But actually in industry, we avoid comments as much as possible. Because if we've written code that explains what's going on, we don't need comments. So that's a horrible thing to bear in mind. And you are in a catch-22 where you have to have comments, otherwise you can't award the marks. And that's pukey and horrible, but let's change the system. Let's start a revolution today. So that's kind of where we're at. And that's there, and we would change that then. Let me show you the same thing in C#. And then we'll talk about where we could do, what we could learn from this, and then I'll take some sort of questions and answers then. So this is the exact same thing in C#. Where we have a slightly different layouts. We have these annotations in C#. So where we had a sort of test bench in Python, we have a test fixture that sort of shows the range of tests that's there. And then we label this with test. If I was to comment out that little test bit, that just becomes a standard function. The test framework that's running here doesn't know that that is a test unless I have the test little annotation above it. That's how it works. Now, here we've got the same pattern. So quality reduces with age. Okay, so as it gets older, we arrange it, we act, and we assert. Okay, the pattern is the same no matter what language or framework you are using. It should be a case of almost anybody can jump in, read that. Okay, I should be able to take this to my granny and she'll understand what this test is really about. And then I can see that I'm doing some setup. I'm carrying out the execution of what I'm trying to test. I'm generally calling the function or the method. And then I'm doing the assertion, and that's where the syntax is different for different languages. But fundamentally, there will be an assert or a keyword like that to make it appear. So the same thing again. Quality reduces faster after selling. Okay, so here the sell-in 0, and I'm just going, what happens? Bang, it drops down twice as fast. That's what I'm testing for. I'm not taking it for granted, and I'm explaining it to whoever comes next. I'm saying, here's a rule. See if you reading all the readme. See if you finding out, does this actually work? That's us more or less up and running and going through. And then we get to the same ugly things down here, right? So here's sulfurous never changes. Here's the item comes in. Here's me calling it whatever number of times and then checking to see what's going on. Well, actually, I can assert this differently. I could turn around, and I'm going to be a little bit terrible. I'm probably going to use a 4i. There's more modern versions, but we'll do this for now. Anybody want to tell me off yet? No? No? Okay. Well, I'm immediately going to refactor because it's annoying me, but no I's, J's, or K's, please. So I'm going to refactor and rename. Do encourage your students, if you can, to not just change one variable at a time, because then it gets lost. Get them to use the tools in Visual Studio or Visual Studio Code to refactor, to change names, change variable signatures, and then it changes them all at once. So I'm going to call this my update count. And it's going to start at 0 and going to go up to 10. So every single one of those I want to assert. I'm going to move this that the sulfurous hasn't changed, and then I'm going to update the quality. Well, I'll do it first. It doesn't really matter. And what I've done there is I've shortened my code down, but I've made it more reusable. I've turned around and said, well, actually, I'm calling this thing 10 times. Let's create a loop that does that for me and make it work. And I hope, I haven't tried this, but let's hope that when I run this particular test, it might give me an error of some sort. But there, it looks like it's running, it's thinking about it. But it should cycle through then. And that's actually given me a better coverage than what the last test did. Yes, success, that's always good. Because the last time I was acting 10 times and then doing a single assertion. This time I am acting 10 times and asserting it on every opportunity. I'm testing that in depth. I'm converting what I'm doing here. And then the same thing here, where we could turn around and I could change this into 5 different tests. I could start to bring a loop in, so I'm looping through these bits in particular, so I'm carrying those things out. That's where I'm looking to take what's working in my head and convert it into something more efficient in terms of code.
No.
So don't be afraid of your normal coding conventions. Use them, because tests are code. So that's kind of roughly where we're at. What I would say, and I'll maybe pop into the Python again just so you can see it, because we spent more time in Python last week, is if I was looking at this now, okay, this is a disgusting piece of code. This function starts on line 8 and finishes on line 36. That is 28 lines of code. Industry has suggested that 10 is the longest a method should be, and ideally no more than 5. And what that means is then we have to start to split it out. And as we split it out, we can test those individual parts then. So the more we split it, the more we can test it. Aha, magical. That's where we want to go, because then the more we test it, the more we're sure each part works. And the more tests we put in, the more we're explaining the context and the rules and how the program actually works for someone else jumping on. Now, what I would look at here is I would turn around and say, okay, I have, where are we at? What do we pick out? What looks particularly, yeah, look at that, right? If the item name is not sulfurous, then I'm doing stuff, okay? And then later on again, if the item is not sulfurous, then I'm doing stuff. And then I've got, if the item name is not sulfurous, then I'm doing, something feels wrong there. That feels like I've spat code out as I've thought through it rather than coming up with a solution. What unit testing will allow us to do is to make changes and know the changes we've made haven't broken the system. Okay, so I'm going to make a change and hope it works. And if it doesn't work, the test will tell me. It'll be fine. So what I'm going to do is turn around and say, okay, I have this check in place. So I'm just going to copy this statement. I'm going to come up to the top of this loop and I'm going to paste at the top, if the item name is equal to sulfurous. So I'm changing the logic. I'm going from being negative to positive. We're very good at ruling things out rather than ruling things in. You'll find your code generally shortens if you rule things in. So I'm saying if it is sulfurous, what do I want to do? Well, actually, we said it never changes. It stays the same. So I'm going to turn around and I'm just going to put a continue word in here. That means it goes from being in this loop to the next iteration round. I'm not doing anything, so therefore it should be okay. And what that means is that I could, in theory, turn around and take that line and say, well, I've checked for that already. I don't need it. I'm getting nervous now. I've checked for that line, so I don't need it. And I should probably move that indent in for the Python. And I've checked for that, so I don't need that anymore. And by writing one line of code where I flip the logic, I hope, I've shortened my code by 3 other lines. I hope, maybe. How do I know it works? Well, actually, here we go. Run my tests. Now I'm using PyTest. I put the -v because I like verbose. I like having more detail than I need just to give me details. But here we go. Da, 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 da. Yes, it passed. Woo-hoo. I've made changes and I'm sure that the program still works in the same way. If I have enough units and I've covered the tests and I've covered the program with those tests, and I've changed the logic and I've broken it down and I've extracted parts. If I'm confident in my tests, I can be confident that any changes I make work. Breathe. And that's what testing should do for us. That's what testing should do. It should give us confidence, security by design. It should allow us to focus on how we do things and make things better that way, and give us surety when we're going forward that any changes we've made or any implementations we've done should work. And it's a very simple, straightforward process. A really good test name explaining exactly what it does, followed by a range, laying out what we need, act, the event, the method, the call to whatever it is, and assert. What do I expect to get back? And all of your different test libraries, regardless of the language, will have lots of different options for you to check. It's not just equals, it could be not equals, it could be ranges, bigger than, less than, matches, is similar to, rounds to, is close. All sorts of options, great fun to play with, need another 6 hours. But there we go. So that is my quick explanation for unit testing. I'm going to say, hopefully, that we'll have some Q&A and I'll answer what I can. I'm going to get a little plug in. Sorry, Sinead. We have a newsletter that comes out every 2 weeks or so. If you go to install.co/subscribe, it's in the PDF, it's on the repo. Within that, you'll get little links every 2 weeks. Some of them you'll not care about, some of them you will, but regularly we have things about testing, about security as a result of doing these things better. And little things like that might be things that you're interested in, they might be things that your students are interested in, and just give you the chance to maybe read or watch something else and really give this a go, because half an hour is mad, and that's kind of a squeeze. But thank you very much. I hope that was useful. And if there's any Q&A, I know I'm tight for time, but I'm happy to stay on for a wee bit.
Thanks a million, Andrew. I personally find that really engaging. The last week's session and this week's session, we're right on the button of 4 here. In fact, we've just gone over. So I'll give the teachers a chance if anybody's got one question, or otherwise they're going to have access to the content on the GitHub link that you've shared. So we'll just see if anybody has a quick question. Andrew, if you want to put that link into the chat as well, that install one,
yes, I
for
will,
handiness.
Surely. Yep.
Just in case folks are thinking of questions.
Everyone's just so keen and excited to play, they don't want to talk to anyone.
Well, I think maybe what folks might do is take last week's content and this week's content, you know, and take a look through that and sort of distill it in their own minds first. And then obviously the content's all there on GitHub. We're also going to share the recording from the last 2 sessions. And then what I would suggest is, if you're okay with it, Andrew, if anyone has questions that they come up with after sort of re-reviewing the content, they can ping that through either to me or Danielle, or even directly through to yourself, Andrew, if that's okay.
I've just popped my email in there, and if anyone
Yeah.
wants to reach out, email, LinkedIn, you'll find me either way, and we can get sorted that way.
Perfect. Okay, well, I'd suggest then we're a couple of minutes over, so we can bring this session to a conclusion, but really appreciate your time in preparing this, Andrew, and coming along and sharing on a great topic. And thanks for folks for joining the call.